as I was saying that for an isosceles triangle, if I'm drawing from the point A, that is from the vertex of the equal sides, if I'm drawing a straight line to the midpoint of the other side, then this angle has to be 90 degrees. Why should this angle has to be 90? It can be proven by congruency. How can it be proven by congruency? Actually, you have done this already as a sum. You have done. You have not done this
Yes.
as a theorem. See, these two sides are equal. These two are equal, right? And this is the common side. Therefore, by SSS, you can say that this triangle and this triangle are congruent. That means I don't know whether this is 90 degrees. Let me erase this. Okay. So these two triangles are congruent, right? So therefore, once these two triangles are congruent, these two angles must be equal, right? Let us take them these angles to be x. Since they are angles on the same straight line, so you must have x plus x must be equal to 180 degrees. That means 2x must be equal to 180. That means x must be equal to 90. That means I have shown that this is a right angle. Okay. So that is what you must realize here. That since from C, if I am drawing a line here to the midpoint of the third side, then this angle here must be 90 degrees. This is an isosceles triangle. This length is x plus 2. This length is x plus 2. So C must be the vertex of the equal sides. Okay, where the equal sides intersect. From C, I am drawing a straight line to the midpoint of the third side. So that means these two triangles must be congruent. This triangle and this triangle here, they must be congruent. And therefore, just as above, I have shown x plus x is equal to 180. You can say that this is 90 degree. Okay, so that is what goes. Now, this actually you should be proving because of congruency, but the proof is going, but the sum is going to get very long if you are, proving congruency. So what you do is you directly say that it is this angle must be 90 degree. Now, once you know this angle to be 90 degree, this triangle here becomes, you get two right angle triangles here, right? You get this right angle triangle here and the other right angle triangle just adjacent to it. You can consider any of the two right angle triangles. So in this right angle triangle, if I consider this one, this right angle triangle, triangle CMS, okay, if I consider the right angle triangle CMS, then CS will be the hypotenuse, CM will be the perpendicular, and MS will be the base. So by Pythagoras theorem, all the three sides are linked. So we'll say in triangle CMS, CS square is equal to CM square plus MS square. Now let's see what are the lengths of each. We actually want to find out the length of CM because CM we don't know. CS we know as x plus 2. Okay, CS here is x plus 2. We write x plus 2. CM, the length of CM we need to find out. So we write CM as it is. And MS, we know the this is the radius of the semicircle. Okay, so this is 2 centimeter. We write 2 square. So that means what is CM square? CM square is x plus 2 whole square minus 2 square, which is x plus 2 whole square minus 4. Can expand this also, x square plus 4x plus 4 minus 4. So this cancels. You simply get x square plus 4x. Therefore, what is CM? CM, the length of CM is root over of x square plus 4x. So we have managed to find out this length here, CM. Now, once we have managed to find out this length, now we know that the radius of this triangle is, this circle is x. So what you do is you produce this straight line so that it meets the point of contact here. That means this must also be x. So this here, this length is x, and this length we have found out to be root over of x square plus 4x. This is what we have found out, the length. Okay. So that means what should be the entire length here? This entire length. Okay, let's call this point T. Then what is empty? Empty is x plus root over of x square plus 4x. So we write therefore empty is equal to root over of x square plus 4x plus x. Right? This length x here you add up, and this length here you add up. You get x plus root over of x square plus 4x as the length empty. But what is empty? Can anyone tell me what is empty?
Radius of the circle.
Radius
Biggest
of the
radius.
largest semicircle. And what is the radius of the largest
Yes,
semicircle?
sir.
It is 4 centimeter. So therefore empty must be equal to 4. Also empty is equal to 4 centimeter. Right? Radii of the semicircle with diameter 8 centimeter. Therefore, what can I say? Root over of x square plus 4x plus x must be equal to 4. Now we simply solve this equation to get the value of x. We need to find out the radius x. Root over of, what you do is you keep the radical on one side and you take everything on the other side. So 4 minus x whole square. Now in order to remove the radical, you square both sides. I've written square here, so square is not required here. So squaring both sides, we get, first the radical gets removed, the x square plus 4x, and now you get a square on the right hand side. You get x square plus 4x is equal to, expand this, this is 4 square minus 2 into 4 into x, 2ab plus x square. So x square and x square cancels from both sides. You simply get 4x is equal to 16 minus 8x. That means 4x plus 8x is equal to 16. 12x is equal to 16. That means x is equal to 16 by 12. That's it. Cancel this with 4. So this is 1/3 centimeter. That is the radius of the circle. So that was the catch here. The catch here was to identify that if we are drawing a straight line from C to the midpoint of the opposite vertex, it must be perpendicular. Once you know this, then your problem is solved. Okay, I have actually written this here, the entire problem here, in a proper manner. You can go through this, because if I write here in the proper manner, it's going to be take a lot of time. That is why I stressed on your understanding of the problem more than writing here. Okay, because this problem can be graded as a tough problem, a difficult problem. Next, number 6, length of the direct common tangent.
So you will give this question in the exam.
As I said yesterday, whether I can give. It's not that I cannot give, but you will have choice. But now, direct common tangent. Just just to refresh your memory, there are two kinds of tangents to a circle: direct common tangents and transverse common tangents. What are direct common tangents? This kind of a tangent is called a direct common tangent, because this tangent is common to both the circles, right? And you can also have tangent like this also. Let's say this is a point. This is a point of contact, point of contact, point of contact, point of contact. Such tangents are called direct common tangents. Okay. What are transverse common tangents? Transverse common tangents are drawn in a slightly different manner. They this also requires two circles because we are talking about common tangents here. So transverse common tangents will look something like this. Okay, if I consider this to be a point here, point of contact, although it looks like a chord, but I did not intend to draw. This is a very rough diagram. Even this kind of a tangent is called a transverse common tangent. Okay, so that is, there are two kinds of there are kinds of tangents to two circles. So here we are talking about the direct common tangent, and the question is very direct here. Calculate the length of the direct common tangent to the circles of radii 3 centimeter and 8 centimeter with centers 13 centimeter apart. Okay, so let's draw the two circles. So these are your direct common tangents. Question number 6 here. Points of contact P. I've called them. The diagram is not given. You must note this. Okay. This is your A and this is your B. So what I do is I join the radii. I join this radii. And I join the centers also because distance between the centers is also given. So I join the center. Okay. And what I do is, yeah, okay, fine. This is my diagram is not complete. I might require one or two more constructions. So this is when we are finding out the length of the direct common tangent. This is what our construction will be. We have drawn a tangent, and just need to find out the length of PT. This we need to find out this length. Okay. In this case, what you do is you draw a perpendicular from B on the radii AP. This is a construction. Okay, let us call this point M. So we draw BM perpendicular to AP to complete the rectangle. To complete the rectangle PTBM. PTBM. So as to complete this rectangle here. This forms a rectangle. Okay, in which PT is one side of the rectangle. Okay, now what is given here? Radii is given. The radius of this circle, this length AP, is given to you as 8 centimeters. This length is given to you as 3 centimeters. And the centers are 13 centimeter apart. That means distance between A and B. This is given to be 13 centimeters. Okay. Now, once we have completed this rectangle, we'll only look at, this is a very, very standard method, okay, of finding out the length. There's another method which I have given you. That is actually a better method of finding out the length of the direct common tangent. From that method, you can also find out the length of the transverse common tangent. If you look, this is the right angle that we are forming here. Right angle triangle ABM. In this right angle triangle, this 13 centimeter is my hypotenuse. Okay. And what is this length here? AM, the base of this right angle triangle. The base of this right angle triangle, if you see, this entire length is 8 centimeter. this length is 3 centimeter. That means this length must also be 3 centimeter. That means this length here must be 8 minus 3, which is equal to 5 centimeter.
5.
So AM must be equal to 8 minus 3 equal to 5 centimeters. And AB is equal to 13 centimeters. So we have got the hypotenuse of this right angle triangle and we have got the base of this right angle triangle. That means now we can find out the length of the perpendicular, that is BM, from Pythagoras theorem. So we apply Pythagoras theorem in this right angle triangle. So we write in the right angle triangle ABM, AB square is equal to AM square plus BM square. That means AB square is AB is given to be 13. AM we just found out to be 5 centimeters, and BM we need to find out what is BM. That means 169 is equal to 25 plus BM square. BM square is 169 minus 25, which is equal to 144. That means BM is square root of 144, which is 12. Okay. So this BM here is, this length is 12 centimeter. And because PTBM is a rectangle, therefore BM must be equal to PT. Opposite sides of rectangle are equal. So therefore, what is the length of the direct common tangent? The length of the direct common tangent is 12. So hence, length of the direct common tangent PT must be equal to BM, which is equal to 12 centimeter. Since PTBM is a tangle. Okay. So I stop here for today.